2F, exponents and radicals continued. At this point, we're going to talk about radicals. Well, what exactly is a radical? Some of you may not be familiar with that term. A radical, it is something that you've seen before, you just may not have heard it referred to that way. That's a radical. Well, radical, wait a second, that looks like a square root to me. Yes, radicals are the same thing as nth roots. We call this symbol a radical symbol. And that symbol, in reality, it has an index and a radicand. A radicand. So the radicand is what's being operated on by this radical. That index tells us what root we're taking. You've heard of a square root or a cube root maybe. Well, that's the index of the radical. So if I want to take the square root of 9, that's really this, the second root of 9. Now, we've defined in mathematics that if you do not put an index in here, that we treat it as a square root. So the actual index of this is 2. Now what is a radical doing, or an nth root doing? It's basically doing the opposite of exponents. If you took 5 and cubed it, then you went 5 times 5 times 5 is equal to 125. The radical, or the nth root, does the reverse of that operation. If I take the cubed root of 125, that's the cubed root of 5 times 5 times 5 is 5. It's basically asking, what number can I take this many of and multiply them together to get this? So, what number can I take 3 of and multiply them together and get 125? I can take 3 5s, 5 times 5 times 5, and multiply them together, and I get 125. So the cube root of 125 is 5. You could even rewrite that as the cubed root of 5 cubed. And then we can see the opposite operations going on here. 5 cubed, the cubed root of that. So if I cube it and then I take the cubed root of it, I pull it back to where it was, and I make that 5. So that's what a radical or an nth root is doing. It's saying, what number can I multiply together this many times to get the value that's in there? So let's look at a couple of them. The square root of 36. So since it's a square root, I didn't put the index there. But what am I asking? I'm asking what number, if I take 2 of them and multiply together, or if I multiply it by itself, will give me 36. So I can look at that and go, well, that's 6 squared, right? 6 squared is 36. So I'm taking the square root of 6 squared, or 6. What about the cubed root of 27? Well, I'm saying what number, if I take 3 of them and multiply together, will give me 27. 3 times 3 times 3, 3 times 3 is 9, times 3 is 27, so that would be 3 cubed. As soon as we can get the same power under the exponent as we have for our index, we can get rid of the power and the radical. So I've got a 3 and a 3 here, so that cancels out, and we've got the cubed root of 27 is 3. Now, sometimes we may recognize them. They may be pretty easy. Those aren't too bad. It is very important for us to know our multiplication tables, right? Because if we're taking the square root of a number, then it's really handy if we know our multiplication tables, because then we can, if they're a perfect square, a squared is a perfect square, or I should, if a, okay, so I should say a squared is equal to a perfect square, if a is a whole number. So basically, if you take a whole number and square it, the result is a perfect square. Which, if you have a perfect square and you take the square root of it, you're going to get a whole number. So the square root of a perfect square is a whole number. So that's where our multiplication tables are going to come in handy, because we can now take square roots of some numbers and go, whoa, I know right away what it is. I did not want an S there, okay? So I take the square root of 25. 25 is a perfect square. That's what we get when we go 5 times 5. So the square root of 25 is 5. The square root of 81. 81 is a perfect square. It's 9 times 9. So the square root of 81 is 9. So anytime we have a perfect square, then it's very easy for us to find the square root of it, because we know our multiplication tables. Now obviously we could get into some larger stuff, like the square root of 256, and you may not recognize that off the top of your head. It's not a single digit number squared, so that's where we may hazard a guess at it. 256, I don't know, what if I go 15 squared? Well, if I go 15 squared and I plug it into the calculator, 15 squared gives me 225. Okay, that's not big enough. Well, what if I go 16 squared? I plug 16 squared into the calculator, or do it on paper, doesn't matter, and I get 256. Ah, the square root of 256 is 16. Now, of course, taking square roots, we don't always have perfect squares here. It'd be nice if we did, but we don't, but that's why we have calculators. We can also run into perfect cubes. Right, that's what I demonstrated with where I had this cubed root of 27. That was a perfect cube. I take a whole number and cube it, and I get the value. But you don't always have that either, so that's where calculators come in. So I'm going to grab the calculator. I've come back with my calculator, and let's do the square root of 57. Now, I can look at this and I can say, well, 57, that's not a perfect square. So I know I'm not going to get a whole number as a result. With that, I probably want to look at it and say, you know what? I'm going to round it to 2 decimal places. An instructor or someone you're working with or for may say they want a certain number of decimal places, but let's do 2 decimal places. Now I look at this and I can go, well, 7 squared is 49, 8 squared is 64, so I know this is going to be somewhere between 7 and 8. But let's plug it into the calculator and see. So I go in here, I find my square root button, and your square root button, depending on the type of your calculator, usually it just has a square root symbol on it, so that makes it pretty easy to recognize. So there's a basic square root button. And sometimes you have a button that allows you to choose your index. Okay? Most scientific calculators will have that capability too. So just be careful, make sure you grab the right one, because if you're taking the square root, you want this button. If you do this button accidentally, it's going to take whatever number you already have in your calculator and use it as part of the calculation. You're going to get the wrong answer. So if I want to take the square root of 57, I get my square root button, then I go 57, enter, and I come out with 7.549834435, and it keeps going on forever. It's an irrational number. But I said, hey, I want to do this to 2 decimal places. So I come over here, remember that's a 9. So I have the 4. I look to the right, I've got a 9. It says I round up, so 7.55. So the square root of 57 is approximately 7.55. So that's pulling it out of our calculator. Well, what if we want a cubed root? And I do suggest that you practice with your calculator and try some of these to make sure you know how to plug it into your calculator properly. But if I want to take the cubed root, what if I want the cubed root of 61? Well, then I can look at it and say, first of all, and we may be able to pull this out, 4 cubed is 64. 4 times 4 is 16 times 4 is 64. So it's going to be less than 4. 3 cubed is 27, so we know it's somewhere between 3 and 4. So that should help you. If you can approximate, you can kind of look at it and say, well, did I get the right answer? So if I want to do the cubed root, then I have to find that button on here. And remember what I said earlier when we talked about calculators was that if you're dealing with a graphing calculator, many times you have to dig through a little more to get the thing. So I actually have to click on the math button and go down to my x the root function. So now that I did that, I can go, okay, I need 3, so I'm going to 3, math, x root. So now it's going to give me the cube root of 61 equals, and I get 3.936497183, or I can say 3.94. Remember, we're looking at that next digit to cause us to round up. So the cubed root of 61 is approximately 3.94. Now realize that any time you have a non-perfect square or a non-perfect cube, when you take the square root or the cubed root, you're going to end up with an irrational number. It's going to go on forever. That's all there is to it. Okay? So keep that in mind. But that's how we deal with square roots and cube roots. And there are iterative methods that we could use to find a square root or a cubed root or something, but I really don't want to deal with that because you're never really going to use that process. But this is always a good thing to recognize and know how to use your calculator to do it. The other thing I want to mention is I've been using these terms, square root, cubed root, right? We could have something like the 5th root of 72. The 5th root of 72. So I take the 5, I go into my math functions, and I get my x the root. So that's a 5th root of 72. 72 equals, and I get 2.35 approximately. I rounded to 2 decimal places. So we can deal with any root. But I just want to give you some special terms to make sure that you're aware of them. If you take any number and raise it to the 2nd power, we refer to that as squared. So it's a to the 2nd power, or a raised to the 2, or a squared. If you take any number and raise it to the 3rd power, we can refer to that as cubed. So that could be a to the 3rd power, a to the 3, or a cubed. If you have the nth root of a number, and we make that the second root of a, we refer to that as the square root. So the square root of a, and like I said, we can get rid of that 2. We don't write that in because it's assumed if we don't have an index that the index is 2. And if you have the third root of a, we refer to that as the cubed root. The cubed root. So just some special terms. We really don't deal with ones to the 4th power. We just call it to the 4th power, to the 5th, to the 6th. We don't deal with an index of 4 or 5 or 6, at least not giving it a special name. So we may have an index of 5, but we don't call this the penteth root or anything of the sort. But these are used regularly: a squared, a cubed, square root, cubed root. So those are definitely terms that you should be familiar with and able to recognize. So I definitely suggest that you go through, play with some on your calculator, and see what happens. Make sure you know how to use your calculator properly for this, because as I said, I run into a lot of problems where people plug it into the calculator and they use the wrong button, or they plug things in the wrong order and it gives them the wrong result. So remember, GIGO, garbage in, garbage out. You plug it into the calculator wrong, you're going to get the wrong answer. So that's dealing with radicals.